Alrighty. So, last unit was all about like congruence, proving things are congruent, and then matching, corresponding parts, and what would be like equal kind of parts there and stuff like that. Okay. Um, so, Caroline, you got the marker there coming to you. All right. This unit, our focus is all going to be on similarity, right? Similar figures. And then determining, based on those similar figures, like the relationships between sides and angles and all that stuff too. Okay, so we'll jump into that here. But I think, actually, yes. Let me do a brief introduction here. If you guys want to write this stuff down, you can. I don't think you're gonna need to super worry about it or whatever. But just in case, if you want to, you can. It's up to you. Okay. So actually, I'm gonna hold off on getting into the book just a sec, just so we can kind of have some basics down. But again, you guys, if you want to write this down, you can. But you might not feel the need to, and that's okay. I understand. So just follow along if that's true. Okay. I just want to talk about ratios and proportions real quick from our notes, and then we'll talk about similarity, and then we'll jump into what we're going to do. Okay. So, a ratio. Okay. We've heard the word before, right? All it does, it just compares two measurements, or no, actually, we'll do this. Two quantities. Okay, or numbers. Right, so quantities would be like something in context. Okay, so again, this is not in the book. It's just kind of a separate little thing here I want to show you. Okay, just kind of make sure we're all on the same page with this stuff. It's this old stuff you've learned about before, but just in case. Okay, so ratios that you hear about in everyday life, right? For example, in your car, right? You have to drive a certain ratio on the road, or else, you'll be considered to be driving dangerously, right? And you'll be pulled over and get a ticket, or jail time depending on how bad your ratio is. But that's the ratio of miles per hour, right? Miles to the number of hours, the amount of distance you're traveling in a certain amount of time. Okay, that's a ratio, right? Another thing you might worry about when it comes to cars, right, is your miles per gallon. Especially, if gas prices go really high, you want to try and get as many miles out of that gallon of gas as you can, so that way you're filling up less than less than you need to, I guess, or less than, save money that way without having to buy it. So stuff like that, right? Your fuel efficiency. That's another ratio you might see in common. The way we write ratios, right? There's different ways to write it. You can write ratios as A over B, like that. A fraction is a ratio. Okay, ratio is a fraction. Alternatively, you could see ratios written this way. Okay, A to B, like that, A to B. Or you could literally just have the phrase A to B written out like that. Okay, all three of those are describing the same ratio. A over B, A colon B, A to B, all mean the same kind of quantity or idea. Okay. A proportion, which normally we talk about ratios and proportions kind of in the same breath, but they are not the same thing. They are related. Okay, a proportion is an equation, okay, stating two ratios are equal. Okay, an equation stating two ratios are equal. Okay, so for example, A over B, right, equal to C over D. Okay, that is the ugliest D. There we go. Okay, A over B equals C over D. Okay, and of course, if A over B equals C over D, then by cross multiplication, A times D equals C times B. Right? If A over B equals C over D, then A times D equals C times B. And again, that's the cross multiplication there. Okay, so that's one little thing. And then another little thing I want to jump into, again, before we jump into what we're going to do today, okay, in the book, I want to talk about just similar figures. Okay, similar figures. Okay, We say two figures are similar if corresponding angles and when we say that word corresponding, what's another word that we sometimes use in place of corresponding? Like if two angles correspond or two angles or two sides correspond, they kind of what? Oh, okay. Well, matching. Matching. You can also think of matching. You can kind of think of it that way, like matching, right? The pair. Okay. So if corresponding angles or if matching angles are congruent, okay. So in similar figures, similar shapes, corresponding or matching angles need to be congruent, and corresponding or again matching sides, okay, are proportional. Okay, so two figures are similar if corresponding angles are congruent and corresponding sides are proportional. Okay, so let me show you what I mean. Let me draw a little picture of that. Okay, let's say here that I've got. Ooh, I want to be careful here. Yeah. Okay. So we'll draw this little shape right here. And this other bigger version of it here, right? Okay. And we'll call this one WIDM, quadrilateral WIDM. And we'll call this one quadrilateral BEAR. Okay. And the statement to say that these two things are similar is to state that WIDM is similar. Similar, it's that squiggle but no equal sign. Similar means squiggle. Similar is the similar symbol for similar is the squiggle but no equal sign. So similar to, and then the corresponding pieces would be BEAR. Okay? So with that statement being true, that means corresponding angles must be congruent. So for example, W must be congruent to B, I must be congruent to E, D will be congruent to A, and M will be congruent to R. Excuse me. Okay. So in other words, angle W is congruent to angle B, angle I is congruent to angle E, angle D will be congruent to angle A, and angle M will be congruent to angle R. Okay. Angles are congruent in similar figures. Sides are proportional. So if we talk about WI, we'll put that in a ratio with side BE here. And that will be in the same ratio as ID over EA, which will be the same ratio as DM over AR, which will be the same ratio finally as MW over RB. Okay. So, in a way, similarity is like congruence, right? Similarity is similar to congruence, right? Similar and congruent figures both have congruent corresponding angles, right? Similar and congruent figures both have corresponding angles that are congruent. Congruent figures, also the sides are equal or congruent or the same. Similar figures, the sides are in the same ratio. Sides are in the same ratio. So WI, again, over BE is the same ratio as ID over EA is the same ratio as DM over AR is the same ratio as MW over RB. Okay? Ratios are the same. Okay? If these two figures were congruent, what would all of our ratios equal? So if these two figures were congruent, what would all these ratios be equal to? What value, what quantity? Avery? 1, right, because they're the same measure, right? So WI and BE, if they were congruent, well, it'd be a number divided by itself, so it'd be 1. So anyway, okay. So, very good, very good. All right, let's move to, and actually I was wrong. I wanted to go to page 601. So we're going to actually jump to 11.3. We're not going to worry about proving figures similar using transformations. We're going to jump to 11.3 for right now. We will get to some proofs. Don't you worry. Not today, though. So the fun will have to wait till another time. Okay, so sorry. I actually wanted to be on 11.3. All right. All right. So, question? 601. 601. Okay, it's very early on there. So it's 11.3. 11.3. Page 601. All right. So, we just kind of talked about this already, about corresponding parts of similar figures, right? So if you know two figures are similar, what can you determine about measures of corresponding angles and lengths? All right, so here we've got some figures here, and so we want to determine if they are in fact similar. So you know that if figures are similar, the side lengths are proportional, the angle measures are equal. If you have two figures with proportional side lengths and congruent angles, can you then conclude that they are similar? Okay, so if we look here, consider the graph of ABCD and KLMN. So there you can see ABCD, like the darker quadrilateral there, and then there's KLMN, like the lighter, slightly lighter quadrilateral there. Okay. Does it look like corresponding angles are congruent here? Does it look like the corresponding angles are congruent? Yeah, it does. Okay. It does look like they're congruent there. Okay. We're not going to actually measure these. I think it's going to take too long to do that. I don't want to waste our time. I think you guys know how to use a protractor, right? We can figure out some of these angles pretty easily, though. For example, what's the measure of angle A going to be? 90 degrees, right? Okay, and how about angle D? What will that one be? 90 degrees as well. Okay, I have from my previous times doing this one that angle B measures to be about 62 degrees, and angle C measures to be then 118. Okay. Certainly then we can also say, what will angle N's measure be? 90 degrees. Okay, what about angle K's measure? 90 as well. And of course, we can see here, and probably L will be the same measure as B, right? So we'll just go ahead and say that, 62 degrees. And M as well will be 118. Okay, so of course, we could actually measure it to see that they are, in fact, the same, but they are. Okay, I'll just tell you that. Okay. We also want to check to see if the ratios of corresponding side lengths are equal. So we need to figure out the lengths of these things, right? So for example, what is the length of segment AB? Well, be careful. What are these blocks counting by? 2. So it's going to be 2, 4, 6, 7 is the length of AB. What about the length of KL? What is its length? I think it's about 14. I think it's 14. I think it turns out to be 14, yeah. Okay, 7 over 14, very good. Let's do another easy one. How about AD? What is AD's length? 6. Okay, what is KN's length? 12. Good. All right, let's do another easy one. How about CD? What's its length? 4. And MN's length? 8. What about BC's length? How would we determine BC's length? You have to use the distance formula there. That's right. So I'll show that here really quick. So BC, okay, distance formula, if you remember, is the square root right, of your x coordinates subtracted. So the x coordinate for B is 5 and C is 2. So it'll be 5 minus 2 squared plus, and it's the difference in the y coordinate, so it's going to be negative 4 minus 2 quantity squared. 5 minus 2 is 3, squared is 9. Negative 4 minus 2 is negative 6, squared will be 36. And so we get 9 plus 36, so it's the square root of 45. Okay, so BC is the square root of 45. Okay. And let's also go ahead and just take care of ML. So I'll do ML as well. So M to L, we'll do that length. So that's going to be the square root. Let's see here. So again, we'll subtract the x coordinate. So L's x coordinate is 10, M's is 4, so it'll be 10 minus 4 squared plus, and the y coordinates will be negative 8 minus 4 quantity squared. Okay, so 10 minus 4 squared is 6, squared is 36. Negative 8 minus 4 is negative 12, squared will be 144. So 36 and 144, it's going to be 180. Okay. Are these ratios equal to one another? Are these ratios equal? What do we say? Yes. Okay. 7 over 14, what does that simplify to be? 1/2, right? Yeah. We'll hold off on that one. 4 over 8, what does that simplify to be? 1/2. 6 over 12? 1/2. And root 45 over root 180? Also 1/2. Okay, also 1/2. If you guys don't remember, I'll show you real quick here just because why not, right? The square root of 45, the way we simplify that, if you don't remember, is you break 45 up, or you kind of pull out perfect squares. So for example, the square root of 45, that's equal to the square root of 9 times square root of 5, right? Square root of 9 times 5, right? 9 times 5 is 45. You can break up a square root over multiplication. You can't do it over addition. So if this was 9 plus 5, I couldn't break it up. But since it's 9 times 5, this is equal to saying the square root of 9 times the square root of 5. And what's the square root of 9? 3. So it's 3 root 5, right? And then root 180, well, let's see here. That's equal to the square root of 9 times 20. Or sorry, it's root 9 times root 20. So it's going to be 3 square roots of 20. But then 20 can be broken up further too. 20 is 4 times the square root of 5. So root 4 is 2 times 3 gives us 6 square roots of 5. So we have 3 square roots of 5 over 6 square roots of 5. The root 5's cancel, and then 3 over 6, that's going to simplify to 1/2 as well. Okay? And so all the ratios are a ratio of 1/2 there. Okay? Don't fret too much if I went too fast through that square root stuff there. We'll do more of that later too. So don't fret too much if you're still at how we do that. Okay? So then, yes, the corresponding angles are congruent. Yes, the ratios of corresponding side lengths. The ratios are equal of the corresponding side lengths. So can we say the figures are similar? Yes. Corresponding angles are congruent. And the ratios of corresponding sides are equal. Okay. That's how we can say that they are congruent. Or sorry, similar, I'll say. Okay. Now, we haven't talked about this, but what kind of transformation could we use to get the ABCD to match up to LKMN? You guys remember what do we call that? A dilation, exactly right. Okay, and specifically, if we wanted to get ABCD to dilate out to be KLMN, a dilation by a scale factor of what? 2. 1/2 is if we wanted to shrink it down. Since we're going small to big, it would be 2. Yeah, I know we had the 1/2s there too. That's the idea. Okay. And again, we'll talk more about dilations a little bit later, but I wanted to go through this first. Okay? So, let's take a look at this next one here, letter D. Okay, we're asked to consider these two graphs right here. Okay. Actually, I'm just going to tear this page out because it's going to get out of control. Okay. Are the corresponding angles congruent between the two shapes? What do we say? Yeah, they are, right? They're all 90 degrees. So they're definitely going to match up. Are the ratios of the corresponding side lengths equal? Well, let's check here. What's the length from A to B? Yeah, good. It's 8. We're counting by 2, so be careful. It is 8 there. What about from E to F? Yeah, it's going to be, I think it's 14, isn't it? 2, 4, 6, 8, 10, 12, 14. Yeah, 14. Okay. How about from B to C? 6. F to G? 10. Okay, so let's just pause right there. Okay. 8 over 14, what does that simplify to be? 4/7, right? You can divide 8 by 2 and divide 14 by 2, right? Divide by 2, divide by 2 there. You get 4/7. Does 4/7 simplify anymore? Nope, so that's our ratio there. What about 6 over 10? Can we simplify that? 3/5. Does 3/5 simplify anymore? No. Are the ratios of corresponding side lengths equal? No. Are the shapes similar? No. Okay, no. The ratios of corresponding sides are not proportional. Okay, ratios of corresponding sides are not proportional. Now we'll briefly look at this next one because it's like super. You can just like eyeball it and see what the answer is here. Okay. Look at the graph here of PQRS, this small quadrilateral, and then we have the larger quadrilateral WXYZ. Are corresponding angles congruent? No. So can the shapes be similar? No, right? Not similar. Okay. Similar shapes, similar figures, they should look like miniature or larger versions of one another, and they should be essentially exactly that, like blown up versions of one another. If corresponding angles don't match up, they are not congruent, then the shapes cannot be similar. You got to be a little bit careful here, right? Because looking at these rectangles, you might think, they look pretty similar. I mean, they're both rectangles, but you really want to make sure that their sides are in the same proportion, right? You got to check those proportions. Once you have one pair of proportions that are not the same, you don't need to worry about the rest of them, right? We could calculate these, but it doesn't matter. Once you have a pair that aren't the same, you're done. You're done. Okay? Questions on any of that? All right. So let's move on to the next page here then. Take a look at this. Okay. So again, this is just a summary of the properties we already saw that I already showed you in the notes. They're right there. So if you didn't write those down, no worries. They're written down for you right there in your book. If triangle ABC is similar to triangle XYZ, then A and X are congruent, B and Y are congruent, C and Z are congruent. Notice the order, right? A and X, they're the first one. B and Y, they're the second one. C and Z, they're the third pair of angles. And then also your sides are proportional. AB is in the ratio with XY. BC is in the ratio with YZ. AC are in the ratio with X and Z. Okay? So, no surprises there. All right, so let's take a look here at an example. All right, we're going to identify properties of similar figures. All right, so figure EFGH maps to figure RSTU by a similarity transformation. So that means they are similar. Okay, we're to write a proportion that contains EF and RU. List any angles that must be congruent to angle G or angle U. Okay, so let's talk about the ratio, the proportion here. Okay, so EF in this shape, what does that correspond to over here? EF in this figure maps to what over here? RS, right? The first two. So they put that in a ratio, EF over RS. Okay, and then it asks us to put that in a proportion with RU as well. What does RU from this shape map to over here? EH. And notice we put the first EF over RS, the second shape, and so we have to do EH over RU, right? So corresponding parts. We do the first shape over the second shape equals, again, a measurement from the first shape over the second shape there. So be careful with that too. All right? And then, of course, for the angles, angle G is congruent to what other angle? I see. You leave something?
Yeah.
Gotcha. Ah, yes. So G matches up to what in this this quadrilateral here? Well, G's in the third position, so T, right? And likewise, U, fourth position, matches to H. Okay? So now let's look at letter B. Okay? Similar question, but with a different shape. JKLMN maps to figure TUVWX by a similarity transformation. Write a proportion that contains TX and LM. So TX from this shape corresponds to what over here? JN. Okay, that's right. T and X are the first and last letter. J and N are the first and last letter. Okay, very good. All right, how about LM? What does LM from this shape correspond to over here? VW. That's right, Volkswagen. Okay. VW. All right. Angle blank is congruent to angle V. What corresponds to angle V according to this statement right here? Angle L. Yep. And angle blank corresponds or is congruent to angle K. So what matches to angle K? U. Okay. Okay. Moving on. All right. So now let's turn the page here and take a look at some more kind of typical problems that we can expect to be able to do. We should be able to do. Okay. All right, and then I'll get you guys started on your assignment here. Give you some time to work on that too. All right. So of course, right, we can't help but throw in a little bit of algebra here to make sure that we're able to set up relationships and solve them. Okay, so we skip through this stuff right here. We're just gonna go right here. All right, we'll look at one that's done for us already, and then we'll kind of do one here for ourselves, and I'll have you guys try one too. So letter A, okay, it says we're supposed to, given that the figures are similar, find the values of x and y. All right, so we look here at our diagram. Okay, I see x show up right here, 4x plus 27. Okay, it's a degree, so therefore it's the angle measure for angle C there. Okay. So since this is 4x plus 27 degrees, and that's for angle C, what does that have to correspond or match to over here? R, right? So we can say that 4x plus 27 degrees has to equal what? 95. And so there it is. 4x plus 27 equals 95. You solve, we get x is 17. Okay? So there's the value for x. Okay? When it comes to y over here, oops, I zoomed in too far. There we go. Okay? We have two y's. We have 4y here for side BA. We also have 3y minus 5 over here for side AD. What does 4y correspond to over here? Or side AB matches to what in this shape over here? PS. So you can say 4y over 10, and in fact that's what we do. 4y over 10 is going to be in the same ratio as 3y minus 5 over 5. 3y minus 5 over 5. So you say 4y over 10 equals 3y minus 5 over 5. Be careful here, okay? Please be careful. It's big shape over little shape equals big shape side over little shape side, okay? Please be careful about how you do this. There are multiple ways to set this up. In fact, this is not the only ratio you can set up here, but please be careful about how you set it up, okay? Always put into a ratio corresponding pieces. So the 4y matches with the 10, so 4y over 10, 3y minus 5 over the 5. Okay, you must put them in the right order. Okay. To solve this, you can cross multiply if you want to. They kind of solve it in a bit of a unique way, but you could cross multiply. 5 times 4y would give you 20y. 10 times 3y minus 5, well, you have to distribute there. So the 10 would distribute to the 3y and the minus 5. And so you get 30y minus 50. And then you can solve. So I don't know, I'll subtract the 30y over. I get negative 10y equals negative 50. And so y equals 5. Okay, we get the same answer. They just do it a slightly different way there. Okay. All right. Let's try letter B. All right, let's take a look at this one here. Okay. Let's solve for x first here. So go ahead, take a look at letter B. Call on someone here. Okay. So let's see here. John, I see here that, for example, angle y, it's labeled as 4x degrees. What does angle y correspond to over here in this shape? What angle? So angle y here, what is it? Angle M. And so that means 4x we can say is equal to what?
5.
You got it. Very good. Okay. How do we go about solving this, John? What should be our first step here? Very good vocabulary use too. Okay. So 4x equals 5x minus 25. And then? So subtract 5x from both sides, you get negative 1x equals negative 25. And so x is what? 25. You got it. Good job. Whoops, sorry, it's on this one. Okay, well done. All right. All right. Let's take a look at the next one. Here's 2y minus 8. Stephen, this side right here, jk, okay, with the 2y minus 8 measurement. What is jk, that big long side here? What does that correspond to over here?
4.
4. And so we can say like 2y minus 8 all over 4, right? The 2y minus 8 all over 4 equals, and now we need to come up with another pair of sides. Do you see another pair of sides that match up here?
There probably is, but I don't know.
Okay, that's fine. Someone want to help us out. What's another pair of sides that got to match up here? Jackson?
M and Z1.
So mn is 1.5, zy is 1. So you can use those. Okay? So is there a specific way I should put that? Like what number's got to go on top over here? The 1.5's got to go on top. Okay? It's from the same shape as the 2y minus 8, which is also top. So the 1.5's got to go on top too. And then the 1 centimeter goes on the bottom. Okay? So really this is 2y minus 8 over 4 equals 1.5. You could cross multiply here if you wanted to, but 1.5 divided by 1 is just 1.5. We can multiply the 4 over now. 1.5 times, I'll do times 4 on both sides here so you can see that. Okay. 1.5 times 4 is 6. We'll add the 8 over. So that gives us 14. Divide by 2, y is 7. Okay? Questions on any of that? Questions on any of that? Okay. So the good news is, so far, right, it's very similar. Similarity is, much like congruence. The only difference is that sides are in proportions. Okay? Angles will still be congruent, but sides are proportional. All right? So, if there are no questions, let me give you guys your assignment so you can get started on that. All right. I was going to have you guys practice one here. All right. Well, we'll come back to that one tomorrow, maybe. All right. So starting on page 606 in your book, if you just want to circle these or whatever, that's fine. So starting on page 606. Let's have you do five, 7, 13, 15, 16, 17, 19, 20, and 22. Yes. Okay, there you go.
If I could come in for.
Set today? Yeah, I'll make sure to put you in. I'll do that right now because we're going to run out of time here otherwise. So. Yes. Yeah, go ahead. Thank you, sir. Everyone get a chance to mark their books? Okay. And of course, you guys can keep your books here on that back shelf. Just put those books with your other books too there, okay? Put those books with your other books there, that's fine. If you wish to do that.